So let's understand solution of linear equation in two variable. The word solution is pretty important, not only over here, but pretty much everywhere that you come across equations. Wherever you see equation, the word solution will come. So what is a solution? To understand that, let's recall what is a true statement. So true statements are equations which is mathematically make sense. 10 is equal to 10, a true statement. 4 is equal to 2 square, a true statement. 40 is greater than 10, another true statement. What is not a true statement? Well, at the other end we have the false statement. Right? 10 is equal to 11, false. 4 is equal to 3 square, false. 40 is lesser than 10, false. All these are false statement. So why is that required? To understand algebraic meaning of a solution of a linear equation, we need to know what is a true statement and false statement. So let us take a linear equation to start with. I will take x plus y minus 10 is equal to 0, or I'll rewrite this as y is equal to minus x plus 10. It will help us in our graph plotting and stuff, so I've done that. Now let us consider few values, the inputs x comma y, and let's talk about if it's true or false. Right, those values, does it give a true statement or a false statement? That's what we are going to look at. We'll start off with a very simple value, 0 comma 0, 11 comma minus 1, okay, then 8 comma 2, then 7 comma 0. Right, so let's use this and try to figure out what makes a true statement and what makes a false statement. So let's go with 0 comma 0. So I'm going to substitute it over here. For x is equal to 0, y is equal to 0, the equation becomes 0 plus 0 minus 10 equal to 0. I'm using this. So that equation, 0 plus 0 minus 10 is equal to 0. This is a false statement. Okay, next, for x is equal to 11 and y is equal to minus 1, we have minus 1 plus 11, sorry, it's the other way around, plus 11 minus 1 minus 10 is equal to 0. Yes, 0 being equal to 0, a true statement. Next we have for x is equal to 8 and y is equal to 2. So we have 8 plus 2 minus 10 being equal to 0. 10 minus 10 which is equal to 0. 0 is equal to 0. Yes, we have a true statement. Then we have for x is equal to 7 and y is equal to 0. We have 7 plus 0 minus 10. 3 being equal to 0, that's not possible. This is a false statement. So what can we conclude? The one which gives us true statements are, can you guess, are your solution or not solution? Are your solutions. Okay, solutions algebraically mean those values which makes LHS being equal to RHS, or which gives us a true statement. So now, what does solution mean graphically? To understand that, we have to plot the graph. I already have typed in the linear equation that's required. Y is equal to minus x plus 10. So let's plot it, and we have the graph. So to understand the graph, let's look at the values. So let me zoom out. Okay, yeah, I think this is enough. So to begin with, we have 0 comma 0. 0 comma 0 is over here, nowhere, and by the way, this is the line for this particular equation, right? So we can see that it's not on the graph. 8 comma 2, 8 is around somewhere over here and 2 is somewhere over here. not very clear. Let's kind of zoom in or okay, so we are looking at 8 comma 2, right? I think I should zoom out. Okay, not that good, but yeah, we got 8 comma 2. So, okay, now that is missing, so I need to zoom. Yes, we got it. So 8 is over there and 2 is over there, so we can clearly see that yes, 8 comma 2 is a point wherein the line is crossing the line is crossing. Okay, so at 8 comma 2 the line was crossing this point, right? Now let's look at 11 comma minus 1. So to understand 11 comma minus 1, okay, my graph does not permit that. Let us make it so. I need to change this. I need to change this. That's good enough, I guess. So now let's see this. Yes, we have 11. For that, we need to zoom in. Right? And we have 1 over there, but yeah, minus 1. For that, we need to zoom in this way. So we have 11 and minus 1 is a point wherein the line is crossing. Clearly, is it not? So this 2 is a line, this 2 is a point wherein the line crosses. 7 comma 0, clearly 7 is over here, 0 is over here, it's not crossing. So basically, graphical meaning of a solution is nothing but all the points wherein the line crosses the points. Basically that. Solution is set of points or all the points wherein the line crosses it. Okay. So let us take one example. Let me take a example from the graph itself. Say for that, let me zoom in a bit. Okay, that's kind of too much. That's better. So we have 6 comma 4, right? 6 comma 4. So I'm looking at 6 comma 4. Yes, you can clearly see 6 comma 4 is a point wherein the line is crossing. Does it make sense algebraically? Well, when I substitute 6 and 4 over here, 6 and 4 is 10, 10 minus 10 is 0. So we have a true statement. Okay, so we can clearly see that algebraically, which gives us a true statement, are the points wherein the line is crossing the point. Okay, basically line is made up of infinite number of points. So it's like back and forth, right? Okay, coming back to a statement that a line has infinite number of points, so a single line has infinite number of solutions. It makes sense, right? Because all these points are by default solution for a given line. That's why it has infinite number of solutions. So please understand the word solution. Again, you can plot your own graph, you can substitute different values, you can cross verify from the graph to the value and value to the graph. So understand this word because it's going to be used everywhere in math, because you're going to get equations everywhere. It's not only for linear, the word solution is used quite everywhere. So you need not bother with, okay, is it only linear? No, it is for everything. So here it happens to be with linear, right? If not, it's used in every kind of equations. So please understand the word solution. It's going to be used a lot.